It's World Refrigeration Day today, which we've agreed we're a sponsor of. And the topic for World Refrigeration Day this year is next generation cooling. Guess just to start off, Jeff, everybody will be used to traditional chiller systems that provide cooling on demand. I'm going to pull up a picture of EnergiVault, but can you perhaps just explain to people what EnergiVault is and how it's changing this traditional system?
For sure, yeah. I mean, I think most people on the call, probably because you're on the call, I guess you're either practitioners or interested in some way in energy storage and cold energy storage. I mean, chiller systems have been around for quite a number of years, as most people know. Probably from the 40s onwards, there was a small amount of cold storage, usually solid ice systems. But again, I think as David alluded to, most systems are demand led. So if you need that cooling, the chillers come on in varying degrees to deliver a set point, depending on the application, whether it be for air conditioning 12 degrees, or whether it be a cold store or a freezing cold store minus 18 degrees. So depending on the application, the chillers obviously come on to deliver that demand. Over the last 60, 70 years, there have been the application of cold storage using solid ice systems. Again, people may be familiar with some of them. We've lost the image, David. I don't know whether you were trying to change.
Yeah, sorry, I'll take it down, Jeff, just while you're talking. I'll bring it back up again.
That's
you want to
fine.
explain.
Yeah, you can bring the diagram, the schematic up actually as well. So yeah, most people may be familiar with ice storage as it's been deployed typically on dairy farms and elsewhere, where there's short duration peak cooling requirements, often in the case of dairy farms at the end of a bit of a wet string of supply cable, so perhaps isn't the capability to deliver high cooling based on the electrical connection. So ice storage has been around for a while. It's pretty rudimentary in most cases. It's basically building a solid block of ice in a tank around a series of coiled copper pipes, either by direct expansion or by glycol. So effectively, those sorts of systems are relatively inefficient when they charge. You're growing an insulating layer of ice around a cold source, and when you're discharging it, effectively you're discharging a solid block of ice as well. It makes it much more difficult to discharge at high levels and high rates of good cooling. So basically, you have no flexibility in the way that you use that store. That energy store doesn't give you a great deal of flexibility in how you apply it to a cooling system, to a chilled water system. So that has been one of the major constraints for cold energy storage for quite some time now. But EnergiVault is changing that. EnergiVault basically is a system that produces that same latent stored energy, but in billions of tiny ice particles. As probably people will be familiar, you have your ice in your gin and tonic. By the time you've finished it, if you're thirsty, the ice will still be there. If you have a child's slush puppy, which is perhaps a similar analogy, then that will chill down the fluid very much more rapidly because the surface area is so much greater.
So Jeff, sorry, just interrupt there. So EnergiVault is storing cold energy as an ice slurry. We'll come back to the ice slurry, but can you just explain to people how EnergiVault actually integrates into an existing system?
Sure.
I'll put up an image here that I think will help.
Bring up the sketch, the schematic. So EnergiVault is typically applied in a system which has a chilled water circuit. So on the right here, you'll see, what might be a typical system. In this case, as shown as cooling an office block, but it could be a hotel, it could be a food factory, could be a brewery, could be a data center, anywhere that has a chilled water circuit. And typically the EnergiVault system will be connected into that via what we simply refer to as the interface heat exchanger. So you effectively decoupling the EnergiVault system from the glycol-based chilled water circuit, the existing circuit. That allows a couple of things. It allows us to tune the fluid on the left-hand side, the EnergiVault fluid, and again, it's a glycol-based solution, but we can tune the crystallization temperature to optimize the system. So the EnergiVault effectively comprises of three main elements. If you sort of ignore the cooling towers as a fundamental part of the refrigeration, a thermal battery, which is a a volume which contains the ice slurry, the latent energy, a thermal battery charger, which is primary refrigeration plant. In the current case, it's an ammonia system, and an EnergiVault smart gateway, which basically provides the interface for control both to external cloud-based optimizers, which are our developments in the EnergiVault platform, and also connecting to the client's BMS, which is still dominant in terms of how things are controlled, but we'll come on to that later. So essentially, you've got a store, a charger, and a smart intelligent control element connected via a heat exchanger to the system.